time in our history. If you look at a comparison, I mean, if you look at 1990, only 23% of the global population had sufficient income to be classified as middle class. Today, that sits at 45%. And to actually put some effort behind these facts, Autodesk had partnered with a firm called Statista to calculate just how much work we're going to need to do to catch up with that. So for 10 billion people by 2050, we're going to need to have 13,000 buildings a day. And that's a lot of work. This is just globally, not just Pakistan. And then we need to have enough roads and rail to wrap around the earth 30 times every year. Just imagine the large undertaking that we have. That's like about more than 1 million kilometers, like 1.2 million kilometers of roads and rail needed for our global infrastructure each and every year between now until 2050. So more is inevitable since the population is going to grow until that big figure I told you. More is inevitable. The demand for more is driven by demographic changes that are already taking place. Now, as we plan for the inevitability of more, how do we balance this with the reality of less? I mean, we're consuming our natural resources like anything. So we have an opportunity of doing better. And as we plan, I mean, there are questions that we're asking a lot at Autodesk because we believe that along with the inevitability of more and the reality of less is the opportunity of better. That means we have to design things better using minimal resources, minimal time, and all that is possible. So by improving our tools and technologies, we can embrace the opportunities ahead and overcome the challenges before us to build not just better buildings and cities, but a better world for all of us. Okay, I'm going to try to stick to my time as much as possible. Let's talk about BIM. I think Mr. Shoaib Yunus did already cover that, but then again, I'll do it very quickly. Building information modeling, it's a process, not exactly software. It starts with the creation of an intelligent 3D model to capture, explore, and maintain planning, design, construction, operational data in order to improve understanding decision-making, share and use the same consistent data across the project lifecycle. So you basically have a single version of the truth. And while you have that single version of truth, you can respond much faster with processes that are smarter. So basically, I read this whole definition out to you verbatim, and that's what BIM does. Now, let's go and zoom into what really happens. BIM integrates multidiscipline models. BIM works for buildings, roads and highways, infrastructure, dams, hydropower, oil and gas. These are all structures. Typically, a building is designed by an architect, then the structural engineers come in, then the MEP comes in, and the civil engineers. They all have their various contributions, and they put it all into one multidiscipline intelligent model where you get documentation, design review, and then it has quantity takeoff, analysis and modeling, things like clash detection so that you avoid very expensive, sometimes you have to demolish parts of your building. That is typical in Pakistan. Many construction firms tell me that they have to actually redesign things. Lastly, but not the least, you have 4D modeling and scheduling and some ERP integration, which still needs to take place in Pakistan. I'm sure somebody must be doing it here. Okay, so what does BIM do that CAD cannot do? BIM does not waste your time. Actually, with CAD, you cannot do parametric modeling, you cannot do structure analysis, you cannot do energy analysis. BIM allows you to do quantity takeoff, automated quantity takeoff. You can do scheduling, clash detection and resolution, monitoring, let's talk about cloud remote collaboration. That's something that actually helps you improve your quality and productivity while reducing cost and time. So you don't need to actually deliver anything to anybody. You cannot actually collaborate over the web. Okay. So how do we deliver infrastructure? When we have large capital projects, typically they are over budgeted, delayed, and they're not very transparent. 69% are over budget, 25% projects come within the deadline, and 25% of the infrastructure costs, they happen because of rework and change orders. So all the error-prone, costly, and labor-intensive physical drawings and drafting with electronic documentation systems, BIM will help you reduce all the errors and increase collaboration. Now, here's the design effort curve, which I'll show you very quickly. What you typically get, curve number 3, is that the design effort is put in during construction. That's the traditional design process. And what happens as a consequence, the longer you wait, the more the cost of changes. What BIM helps you do, if you look at curve number 4, that's the preferred decision process. That's where you take all your effort and take it towards the design side. When you have that, your ability to impact cost reduces at the end. So if you folks have any questions about this, you can always reach out to me. So the idea is to take it from number 3 to number 4. Okay, and at the end, you have to lower your project costs, accelerate your project schedule, and improve quality. So any examples where who has gained from this? You have there's a Chinese project, the high-tech park design. They have 33% reduction in design times and costs. They know this because they've measured it before and after BIM. With and without BIM, you can tell the difference. You need to be able to quantify what you do. Then you have a quick redesign of interchange. Now you have another interchange, just a second. Okay, so basically this is an interchange in the US. Interchange is basically in what Pakistan mein aap kehte hain chowk hai ya underpass, overpass, bridges. So there were lots of gains because of BIM. There's improved construction planning. There's another one in the US again. US की examples ज़्यादा हैं. Design efficiency बहुत बेहतर हो गई. There were lots of 2D designs. They're moved to 3D. And there's a lot of intelligent design which actually helps you. And I'm sure there will be lots of other speakers who will actually give some examples of it. So BIM mandates, the world has seen how BIM can help. It can save time, money, collaboration effort. And lots of countries have actually decided to mandate BIM. If I were to list all those countries, I think I'd have a very crowded slide. But let's just look at a few so that we can, in the interest of time, we have 6 countries here: Norway, Finland, Denmark, Singapore, and the UK, South Korea. Now, this is a timeline of how they started their initiatives of BIM adoption, and it's just improving. Why did they mandate BIM? Let's just look at the top 3 reasons: energy efficiency, reduced delivery time, reduced cost. In the case of capacity buildings, the UK has actually undertaken that effort because your BIM expertise will help earn you revenue. So with their targets, the targets for 2025 are 33% lower costs. And I think they're well on the way to doing that. 50% faster delivery, 50% lower emissions, and 50% improvement in exports. The export is actually the BIM expertise used for managing foreign projects. So their BIM level 2 is compulsory on all projects 2016 onwards. The European Union, the Parliament is all for it. United Arab Emirates, they started early, 2014. Any building 40 floors and above needs to be done with BIM. 2015, 20 floors and above needs to be done with BIM. and so forth. So any universities, hospitals, offices of foreign organization have to be done in BIM because it saves time and effort and money. If you have any questions, you can always reach out to us. You can take a screenshot of this page. Thank you very much, and I'll hand it over.
Thank you so much, Irfan sir, for briefing. Mr. Farooq, I think you can continue your presentation, and we are happy to hear from you and learn from you, sir. Over to you, Farooq sir.
Thank you very much, Mazhar. Let me formally introduce myself. I'm Dr. Farooq Arif, and I am Director, NED University Virtual Reality Center. And I'm also Associate Professor of Civil Engineering at NED University. Thank you, BIM Pakistan, for inviting me to this forum and its sponsors, ER Solution. I was told that my session would start at 3:30, but I think there was a last minute inclusion. And since we have time only to 4:30, I'll try my best to be honest with my audience who have joined in, knowing that I will start at 3:30 to 4:30, but I'll try to finish it in the time. So just listening to Mr. Irfan, who was explaining us about BIM, and BIM is a very intelligent tool, I would say. But where virtual reality comes in is the visualization of what BIM does, what BIM does or any other such tool does. So because the reason is that BIM can provide you a lot of visualization, but it cannot provide you the real world, real scale visualization, and that is where virtual reality and its integration comes in. So we would talk about what do we mean by immersive visualization to start with, because virtual reality is part of that, and then virtual reality definition and its explanation a little bit, and immersive visualization potential in AECO, that is architecture, engineering, and construction. I would explain you 6 or 7 different examples which have been implemented in Pakistan. So we have worked a lot on different projects in which we have utilized virtual reality for the benefit of the client, for the benefit of the architects, for the benefit of the whole stakeholder team. And we would go through certain projects for that. Finally, I would also explain you some extension with regards to the AR MR examples, which is again an extension to the visualization within the immersive visualization domain, where I would try to explain you, give examples of what we are working on with respect to a mixed reality or augmented reality. And 3-4 quick examples would be discussed as well. All of these examples, of course, are conducted in Pakistan with the help of different companies, with the integration of different companies in Pakistan and across the world as well. So what do we mean by immersive visualization? First, we need to understand the very point. Immersive visualization is basically any technique that creates images, diagrams, animation, and communicate a message. Let me explain you that immersive visualization is not limited to construction industry only or AECO industry. It has vast domain, it has vast application, and in fact, it is being used much more in other commercial areas than in construction. So that is why the general definition of immersive visualization or visualization is any technique that can create images or diagrams, as I said, to communicate a message. When we talk about converting this visualization into immersive visualization, it could be applied to mixed reality, augmented reality, virtual reality. So the degrees or the categories of visualization innovation in any field, whether it be construction or any other, includes virtual reality, mixed reality, augmented reality, and immersive visualization itself. Let us, because our topic is how virtual reality can help the AECO sector, what is its potential use in AECO sector in Pakistan. So let's restrict first ourselves to virtual reality. Virtual reality, some of the snaps are being shown here of different systems of virtual reality is a fully immersive, highly realistic experience where a user can wear some head-mounted devices, or they may, such as Oculus and HTC, many of you might be familiar already with them, or we may create a virtual environment into a projection system. Such a system is housed at NED University VR Center, and we call it as virtual projection VR system, where at full scale and in a group environment, people could be immersed into a full-scale virtual environment. And the environment itself is coded as cave environment. So if you look at this, this also requires you to wear special kind of gadgets, but these gadgets are different from what we have in Oculus, where you are isolated from the world. Here, the group immersiveness could be utilized for much of the benefit. While the mostly used version of virtual reality devices or the virtual reality apparatus is, of course, the head-mounted devices or HMDs, as I gave you examples of Rift and HTC. So what I'm going to talk about today are four or five different examples, starting with the virtual reality for infrastructure management, virtual reality for infrastructure manager or infrastructure management capacity building. Then how can we utilize virtual reality for cost planning during the early stages of the project, or what we call a semi-detailed estimating phase. Then I would touch upon a couple of more examples in which how are we doing right now and utilizing or experimenting to use the augmented reality in construction planning for its visualization, specifically that is progress visualization of any construction project, and also how can we use augmented or mixed reality as a town planning example. So I'll show you a couple of examples for that of what we are doing as well. The first project that I'm going to discuss briefly is something which was a collaborative effort between NED University, specifically VR Center, and one of the renowned companies in US, AI Engineers. They have also started their business right now, so I give them full credit for that. Basically, when we talk about virtual reality, there is much more to that with regards to what data set is being provided to generate virtual reality. So different kind of data set can come from actual as-built environment. In this, unmanned aerial systems, or UAS, which what we call as drones normally, they can be utilized to create visualization of 3D models for infrastructure. Then what we call as LiDAR scientifically, but laser scanning in common language, can be utilized to scan specifically inside of a building or inside of an infrastructure facility and then convert it into a 3D model. Of course, building information modeling provides you typically as planned. I'm not saying it cannot do as built, but it provides you with the as planned data set of the 3D model or visualization of any planned infrastructure. So it is an information-based model. Now, these three sets of information are coming from different sources. The aerial planning, of course, would come from the UAS, that are drones. The laser scanning can provide you the as-built infrastructure facility visualization, and then BIM can provide you as planned for the comparison between what is actually being built on the site. If these three are looked at in different models, of course, they provide a lot of information, but if they could be integrated into a virtual model where a user can walk through either by wearing HMD or by projection VR system, the decision making, the hypothesis is that the decision making of such effort could be very much informed, which is ultimately project management. Because what you're doing in project management is managing the risk and managing and making right decisions. So if these three information sets specifically for infrastructure management decision making could be integrated together, the virtual reality can help in providing and or generating immersive visualization that can help engineers, managers, maintenance engineers, etc. To visualize it at full scale and then can use it for better management decisions. Of course, different devices are used for it. They talk in different languages, but they could be combined with very different available softwares, and the data could be processed to come up with the virtual reality visualization. So this is an integration framework that we used. The engineer who was working with me from AI part was Mike AECO. So we basically worked on certain things in US and certain things in Pakistan, where the drone-based visualization, of course, was supposed to be done in US because the facility was there. The facility details I will explain in the next slide. And the BIM data was modeled as per drawings which were basically provided by the designer. Laser scanning was conducted for inside of the building, and these three data set information were then integrated into a compatible interface, and virtual reality visualization was created for all these purposes. The project itself, if you look at this whole facility, this is the rendered BIM image of the facility. It was Connecticut. In Connecticut, specific area was Waterbury Bus Storage and Maintenance Facility. It is a $100 million project. The AI engineers were supposed to basically oversee the project delivery and project management of the whole facility. And the duration of the project itself was between 2015 and 18. So we basically worked on this project towards the end, where we utilized it in 2018 to generate integrated immersive visualization. It was a total 2-story facility, about 400,000 square feet, 30-acre site, and it was a high-performance building providing inspection services, parking services, etc., etc. To the bus. If you can see the actual facility pictures at the bottom of the slide. So what happened was that different data sets were collected. This particular drone was utilized for the different flights, and you can see a flight's video clip, which was utilized to collect data with respect to its surroundings, with respect to its landscape. And then this visualization, let me play it for you. So this was a point cloud data set that was generated out of the aerial visualization or drone-based visualization. This data set, of course, was mainly utilized for the surrounding planning or surrounding documentation of the data of this facility. So you can see the resolution and the image. When you go directly inside to this model, it becomes more and more processed. This is, of course, a lighter processed version of the same visualization, but you can realize that how much cleaner data set can be provided by the drone imagery. The next thing was, of course, to perform laser scanning, and this is a laser scan model of the same facility that provided us with the information of the inside, and the BIM model. Of course, as planned, BIM model was developed for the whole facility. Moving on, all these three models were integrated into a virtual reality visualization through a workflow where the drone data was utilized as kind of a floor plan in typical BIM language, but it was utilized as a base, as one of the layers, and then the BIM model as well as the laser scan model was overlaid onto the model. And if you see this particular video clip, is basically a walkthrough of the facility between two of the participants. This is one of the test sessions video. So there are two different people, one in Pakistan and one in US, and they are walking through the whole facility in VR environment, wearing Oculus Go sets, which are mobile devices, and marking and measuring and inspecting everything. So this kind of integrated visualization can help us, as I said, better infrastructure management. Moving on to the second example, which is a particular study conducted as a derivative of what we did in the previous study, but much more related to capacity building of different people. So the background of the study is same, but what we did was that we created a projection VR-based visualization of the Nipa Bridge. Those of you who live in Karachi are very much familiar with what bridge I'm talking about. So it's at the junction of Rashid Manas Road and University Road. So it's called Nipa Bridge in a common language. And what we did that we basically modeled that Nipa Bridge into a 3D model. So this was the modeling routine. And then two different models were generated out of this. One was the inspection model, because what we wanted to do through this study was to utilize the virtual reality for training and capacity building of infrastructure manager, actually evaluate whether it could be utilized for the capacity building of infrastructure managers. Of course, the ideal thing would have been to have laser scan model embedded into VR, which could be done, but because we were doing it for the sake of assessment of the capacity of VR for learning of the infrastructure managers or potential infrastructure managers. That is why we restricted the scope to learning rather than having the actual as-built model. So the drawings were collected from the government, and then the bridge was modeled. The bridge was modeled, and then the rating system, NBIS rating system from US was applied, which is typically used by us, or a similar rating system is used by us for the rating of physical condition of infrastructure, specifically bridge as well. Now, this picture, if you see, is a snapshot or a 3D snapshot or rendered snapshot of tutorial model in which the participants of the study were basically immersed into projection VR system. We have the capacity of immersing 15 people at a time with an operator or with a moderator, rather. And then some hypothetical physical condition errors or physical condition issues were embedded. If you see the picture A, B, and C, so corrosion as well as different types of cracks were immersed into were basically modeled into the same bridge, and we called it as inspection model. And then the whole about like 100 people, or rather 70 people. We shift over the slide first. So this is just okay. Before I explain you the test session, so this is just a walkthrough of in VR, recorded from the projection VR system, of how this area. So if you see that we took the Google imaging from the available Google Maps, and we overlaid the whole NEPA bridge, which was modeled, whether it was tutorial model or the inspection model. There were two different models. And then, of course, in projection VR system, we work with different languages to make it interactive, specifically C or Python language. This is the walkthrough of the whole. Unfortunately, of course, we did not have a good resolution from Google Maps of the Gulshan area where this actually bridge is situated. But you can see the capability into this. Now, after this, test sessions were conducted. So a total of around 70 to 80 people were immersed, who were basically first. There was a 15-minute session, and out of that 15-minute session, half of the session was to explain the rating system, and then the rest half was to get them immersed again into inspection model and ask them different questions. After that, their feedback was collected to rubric. This is to show you the capability of utilizing virtual reality for the sake of capacity building in infrastructure management in AECO industry. If you look at the aspects that were basically evaluated in this case through rubrics, were regarding the comfort of using the gadgets, the dizziness, the overall comfort, the sense. Other than this, we also had a kind of a small quiz where the immersed subjects were asked to rate on the rating scale, that is NBIS, the different physical deteriorations that were incorporated into the inspection model, and they rated as well. So their remembrance, or what we call in education learning as cognitive learning, was also measured through a different rubric, where they were asked to rate whatever they saw in virtual reality, and they rated it. So those results were also very valuable. But since we are talking about the potential of using virtual realities, I've restricted my results here. So if you look at the overall results, and to conclude it, I would say that there were some issues with respect to the comfort level of wearing the gadgets to some of the subjects, but those were relative. Not everyone was a little bit discomforted by that. The reason is because those people are not used to typically using virtual reality into their normal business work. The idea was that if that data set, which is in virtual reality, did provide them with more comfort of learning, as well as learning in a real world environment, eliminating the need to go on site maybe sometimes, and this is very contextual to nowadays with the pandemic. So sometimes you may not need to have some kind of site visits, rather than even in, say, if I tone it down to the classroom learning, people can learn better in VR environments. So all these aspects were measured, and this was found to be very fruitful. That is the use of virtual reality in infrastructure management capacity building. This is also already a published study, so as the other one. So if you want, you can search online and you can get the published one. Another example which is related to building construction. So in building construction, of course, if we talk about a success of any project, there are three parameters typically. All of us know: time, cost, quality. So what we focused on that cost planning at the very early stage of the project, where the different alternatives might have been discussed. If you talk about cost engineering, so there are different phases in a project's cost life cycle, starting with the evaluation phase, then the conceptual engineering phase, then the semi-detail and detail engineering phase, and then actually the construction phase. So the phase that we focus, and the reason was because a lot of blackout periods. Blackout periods are those where the cost value of a project is somewhat known, unknown. So because the design work is being done, the architectural work is being done, the alternative spec writing is being done. So sometimes there are phases in a project design stage, specifically detail engineering, but we restricted it to semi-detail, where the cost of the project might be kind of blacked out. This is a cost engineering terminology, blackout periods, and these blackout periods happen at 2-3 different stages during the project's cost life cycle. But the blackout period that we actually focused was the period in the semi-detail phase, where the architect, the engineer, the client, they are working together. Architect and structural engineer and the client, they are working together to come up to a solution, or to come up to a final product in terms of design. And that is where there are many issues that the architect might be talking in different with different kind of perspective, and the structural engineer might be talking different. So we thought that this blackout period could be eliminated, or rather it is the result of lack of visualization at this stage. However, whenever you do some kind of scientific study, you have to prove it first, that okay, this is hypothetically correct. So we went to the industry and we found out different visualization bottlenecks that happened during that phase. I'll explain you the results. So the half of the study was actually proving the hypothesis, and the rest half was coming up with a couple of case studies where we implemented this concept of using immersive visualization or virtual reality part of the immersive visualization for better cost planning. And I'll show you those results as well. So basically our hypothesis, the ones in the highlight, the ones which are highlighted or illuminated, were actually to prove that factors related, there were two major hypotheses, that factors related to lack of visualization during semi-detail engineering phase, where the conceptual estimates of conceptual design is being converted into a detailed design, that impacts the cost planning of the project. So this was our hypothesis. And then the second hypothesis was that immersive visualization could be a solution to resolve that. So first we wanted to prove that visualization, or lack of visualization rather, is a problem. And the second, we wanted to utilize visualization, that is immersive form, virtual reality form, to overcome that issue. So we went to the industry and we refined the factors which were identified through different literature, different project, and this focus group, which is the details of which is provided in this table, and then conducted a detailed survey from the whole construction industry of Pakistan who were involved in the building construction. So there was a response rate of 30%. Typically in scientific studies, this is acceptable. And our hypothesis, let me go back. Our hypothesis testing, which is a statistical tool, proved that the ones which are highlighted do really exist. So number one, there is an issue of lack of visualization during the semi-detail or detail engineering phase. The visualization that is typically being done is a 2D visualization. If people are using information modeling, so yes, they do look at it from building information modeling perspective, but a full-scale visualization is still lacking, which ultimately converts into cost overruns during the execution phase. And secondly, we thought that virtual reality as a full-scale visualization tool could overcome this lacking. So we modeled a project which was in the design phase at that stage. It's a nanotechnology center being developed at the NED University. Now the groundbreaking has been done. I think foundation work is also completed. This is way back in 2017 when it was being planned, as drawings were being constructed. So it is a nanotechnology center which is being constructed at NED University. The changes which were highlighted in this, which were not before we immersed stakeholders into, they were different changes. One was related to this beam which is highlighted. Actually, this picture is from the VR stakeholders immersive visualization session, where one of the stakeholders highlighted this beam's depth to be a problematic. Actually, the point was that architect was adamant that a beam had a depth and it was destroying the architectural image of that passage, and it was deeper, and the architect wanted that beam to be more shallow, but the structural engineer had a point of view that no, this is not deep, this is similar to the other kind of beams and it would not hinder that. So these are common problems which now this seems to be a very little problem, but if you think about it, if the structural engineer would have to change the depth of the beam, the design of it, the beam itself and the surrounding frame would have changed as well. So this problem was due to the fact that every time this debate was being done, it was on a 2D plan, on an AutoCAD version of the drawing or on a PDF version of the drawing. And hence both of them might have been correct, but at that stage they were not talking in the same language. That is what my point is. And secondly, there was a position where the elevator well was there, and structural engineer wanted to add up a beam, and then architecture engineer did not want. There were some issues with the height of the stairs as well. So then we created a virtual reality visualization of this whole work of this whole project, and conducted certain test sessions, because test sessions were conducted to prove the usability, to check the model, etc. And these snaps are from test sessions. Then what happened was, okay, this is the image of this is the actual image of the drawing, on which the mistakes were being highlighted and the communication was being done between the architect and the structural engineer. And of course, the client was kind of stuck in between the two. But this is the level of working which was being done on a 2D plan. We immersed all the stakeholders, and I must commend one of the master student at that time worked with me on this, Ramsha. And we immersed this, the stakeholders. This is the architect, the client, and the structural engineer, and the moderator. And they were immersed into a virtual reality meeting of this project. And they walked through this whole building to resolve all these issues. And one of the key issues with regards to the beam depth, as I was explaining, what happened actually, because I was being the viewer in this, you do not see me in being immersed into this. The architect and the structural engineer went under that particular beam, and the architect looked at in the real scale like this on the top, and she realized that, okay, no, the structural engineer was right, and the beam's depth is not that much of a problematic with respect to architectural design. And that issue was resolved then and there. So you can see that just with this small example, there were other 3-4 issues which were also resolved. I'm not going into the details of those because of the time, but you can realize that having a height view, having a full scale view of certain project, certain building to be constructed, can resolve the issues which were being tried to be resolved with these many issues. There were a lot of communication going on for a period of time, and if virtual reality visualization quickly helped us in resolving that issue within minutes. So this whole session basically ran through for 20 minutes, in which a number of issues, specifically mentioned 5 different issues which were there between the structural engineer and the architect, were resolved. So this is the magic, or this is the actually the benefit of it. Now, I gave you 3 different examples of utilizing virtual reality for infrastructure management, managers capacity building, as well as cost planning and control. There are other projects as well which we have conducted in Pakistan. Let me give you some examples of augmented and mixed reality, because that would also open up our minds about how can that help us in better delivery of projects in AECO sector in Pakistan. Now, when we talk about augmented or mixed reality, usually they are being used as a synonymous terminology. Actually, technically speaking, they are different. But I've explained it here combinedly so that we can have the baseline understanding of the both. Now, augmented reality animates the data in a real world scene. If you allow me, I'll explain you the difference between VR and AR in this manner, that in VR, a real person, an artificial environment is created and the person is transformed into that artificial environment. So the environment is artificial, but the person who is transformed into the environment is real at full scale. So that gives him a real world sense. In augmented reality or mixed reality, it's the other way around. The environment is real, but the model is basically brought into the real world environment. Now, this opens up a lot of things, a lot of opportunities for specifically architecture engineering, town planning, as well as progress visualization. Because when you can have the, for example, the virtual model or the 3D model just like on your table in augmented reality environment, in your office, at your room, in your boardroom, even at full scale if you are communicating with different devices together. So that can help you a lot in superimposing what has been actually built, for example, and what is left to be built. So when they are together, combined together, this would give you a better visualization of as planned versus as built as well. So this is the major difference. One is being active in terms of the real world, the artificial world, and the person being immersed into an artificial world, while the other is other way around, that is augmented reality, where the artificial thing is being brought into a real world environment. So mixed reality mixes up aspects, of course, because of that very reason, aspects of VR, AR, immersive visualization, and overlaying of this information into a real world sense or real world context. Usually, if we talk about augmented reality, the name that comes into our mind is a HoloLens or a tablet-based VR. So we are working with HoloLens as well as tablet-based VR as well. Let me give you an example of. So this is a funded project by Ministry of Science and Technology, and we are working on generating progress visualization in augmented reality of a construction project. Fortunately, by the time we got this project, the same building which is I just mentioned for the cost planning, the Nanotechnology Center, is now under construction. So we are doing our case study on that particular building to evaluate the possibility of progressive visualization of construction process in augmented reality. If I just show you, so there are two domains to that. One is to utilize a normal mobile phone or a tablet for the purpose. So this is that visualization. You can see that a paper drawing is on the desk, and the 3D model of that drawing is being superimposed onto that plan. So now the drawing is no more a 2D drawing. It's a 3D drawing in a real world environment. So this is a mixed reality example. This is a small app that we are developing. Other than that, of course, we are trying to utilize HoloLens for the sake, and we are utilizing it. We have done some progressive measurements. So HoloLens, we do have this capability at VR Center, and we are utilizing the HoloLens 2 for that very reason. And the idea is that this is the location of that construction. Actually, this is 15-20 days old picture, but here already the construction work has started. We had the drawings, we had the schedule, we developed the information model for that, and now we are trying to superimpose it into an environment where we can have the already constructed scene through the HoloLens, and whatever is left on the top of it. Many people are doing that in MEP worldwide. We are trying to do that for structural members, specifically in concrete construction. So that is how this study is different from the ones that have already been done. Now, the last example, because we are already on time, the last example is of augmented reality for town planning. I just want to give you an idea, and this again is a video from our own facility. So what we did was, a town planning 3D image just to show you that this could be moved around, put onto the table. So this is a small hypothetical town where we can utilize, upscale it, downscale it, mark it, move it. We can do anything with this. And the meetings, which were kind of bored and different perspective people, they have been talking from different sense on a 2D drawing or a 2D visualization, now can have a virtual model on top of their table and can do the town planning in a better manner. Think about a big table where whole Karachi's master plan is kind of in 3D model and could be implemented. So a lot of discussion, a lot of planning could be done in a better way in this example. So this is all from my side. Thank you very much. I tried to abide by the deadline. And if you have any questions, I'll be very much willing to answer those questions.
Thank you so much, Dr. Farooq, for your wonderful presentation. Anyone, if you have any questions, please feel free to ask. Thank you so much,
Dr.
Saad
Farooq, that was
for the
well
remarks.
presented. Sorry, that was well presented. I mean, we all went on a bit of an overrun as far as time is concerned, but I think I would like to have you present the same thing to one of our audiences. That would be fantastic.
Thank you very much, Saab.
Yeah.
I'm glad that you liked it. And actually, your presentation made a context for it. So I did not have to discuss a lot of BIM, which you already discussed, because then I utilize it as an application part, and that really helped me.
Yeah, I mean, it was a bit hurried, but that's okay. We did it. We did the whole thing.
Yeah, I think that was a good.
Dr. Farooq, I mean, I'm sure you've seen a whole spectrum of attitudes towards virtual reality in Pakistan. I mean, the ones who think it's, oh, kya fayda chodo, until somebody who considers it very important and integral to the success of the project. I'm sure you've seen the whole spectrum of reactions from people. And what have you got to say for those who treat it dismissively?
See,
I might ask you for help.
Yeah, if you allow me, let me take the liberty and explain the horizon of VR. Actually, because this session was limited to use of virtual reality in AECO sector, but there are different, I would say, digestion levels in different industries with regards to VR. So when you talk about these bottlenecks in construction industries, you are very much right. Because the reason is that, but when you talk about it in the manufacturing industry or medical or digital health, the application is much more acceptable. We at the VR Center, for example, are working on different projects with some digital health companies. We have developed some patient simulators. We have developed some other kind of products that we are utilizing. And there the digestion is better for the sake of learning as well as for the sake of implementing. So many of the companies are already using our product. But when it comes to construction, the construction sector is somewhat kind of resistive to technology adoption, sometimes little bit more than what other sectors are. I think the main reason behind that is that normally in construction industry, we are very much drowned into working into day-to-day affairs. When it comes to strategic thinking, it does exist. I would be wrong in saying that strategic thinking does not exist, but the dimension of strategic thinking is lesser towards technology adoption and much towards policy decisions. Now we have to have a balance between those. Actually, when you adopt technology, a lot of policy issues could be resolved as well. So when we talk about the strategic dimension of the industry, I think the technology adoption and utilizing the technology to disrupt the policies would be the right way to go. You gave examples of different countries where the BIM is mandated. I don't see at the moment, actually that is the way to go about. But I personally, if you want my opinion, I don't see that happening even if it is that mandated. I mean, scheduling, for example, schedule submission is a mandatory thing, but you know that what kind of schedules are being submitted in the construction projects, and that creates a lot of issue. So even if you mandate, say, for example, use of BIM or virtual reality, the adoption of the same thing would, I think, it may become more tempered than what it has a potential to do so. So I think we have to go from bottom to up. Then we would create examples of implementation, just like some I showed.
Yes.
Maybe industries can adopt those, and then it would elevate itself. It would be purely based on competition. See, business is all about competition. When people
Yes.
would adopt technology, 2, 3, 4 companies would adopt, the next company or the other competitors would be bound to do that. And I think that is the way to go up with these
Yes,
technologies.
yes, Farooq Saab. Also, we have a question regarding the exact same thing. I think we can also speak about the ROI on the virtual reality, like implementing VR. So, some words on ROI on VR, sir.
That is actually a very good question, because the first thing that comes into mind is cost extensiveness. Now,
Yeah.
see, this is about what level of VR you want to incorporate. Whenever I introduce VR, I always explain that the virtual reality has different levels, different degrees of implementation. If you would talk about getting the highest degree of implementation, of course, that would cost you more, and the ROI in current scenario might not be pretty much feasible for us. Secondly, do not think about virtual reality being used or as that every company would have to buy the equipment for it. I mean, it's like have a service-based concept into this. When you have to get say not now, but when you have to get 2D drawings being developed, you do hire a person experienced with AutoCAD. Now, when you have to do that for virtual reality, you need to have proper setup. So number one, the ideal thing is that every company should have its own information modeling software, own systems, etc. But it's not necessary to have all of those in each company. So those companies who are willing could take the services of different organizations. They can utilize their equipment. At the end of the day, when you do surveying on the site, sometimes construction contractors also get surveying instrument on rent. So why not get these things as a service-based mechanism onto your projects as well? So that is the solution. Number two, how would it return? See, the return could only be realized when you implement into one of your complex projects. What happens is that our baseline, for example, the estimating thing, when we develop baseline estimates to be faulty, then everything that goes beyond that estimate looks like an overrun to us, which in my opinion, being a construction engineer, is the wrong approach. Agar aapka estimate is not good enough, accurate enough, though everything above is not an overrun. It was your mistake at the earlier stage. So you can save the fault that can come around at the construction phase by incorporating this technology at the earlier stages, and that would value up your project. The third answer to this is, of course, numeric answer. It has been observed from different studies, of course, and it is yet to be ascertained in case of in Pakistan, that sometimes the incorporation of such technologies could save you around 30% of the cost in having value engineering and having better planning. Let's say even if it is not 30%, 20%, 25%, it's a big number. If you plan it correctly, it would help you around. So of course, this has to be ascertained in case of Pakistan as well.
Very well answered and well explained, sir. If you have any confusions, please you can ask again, or if you have any questions, please feel free to ask.
Actually, Dr. Farooq, like you said, that when I set the stage for you, it resonates well, especially in that cost curve. Seriously, the real kind of planning that goes into a project, do you think it is really being exercised in Pakistan? Very few firms do it. A lot of them appear to be doing BIM, but in the background, they're actually doing something totally traditional. So
Actually,
they don't go all the way.
Yeah, that is in another whole topic, how we go about preparing our construction documents, specifications, look at the value engineering aspect. That is a total different thing, and there are a lot of complaint about those as well. Of course, from engineering point of view, that how the specifications are wrote, that also create. I think that has to do with a lot of capacity building at that stage as well. And the first stage, of course, is to realize that there is a problem. So that would be the first step to incorporate or resolve it. See, the very studies that I've shown you, the cost one, for example, if I would have implemented it directly, everyone would have said, okay, this is something which is a fancy solution or fancy thing. But I went with my student, of course, into the industry and asked the industry whether these kind of problems do exist. And the hypothesis, which is a scientific way of proving something, proved that. When it is proven, so this becomes the first step to accept, knowingly or unknowingly, that there does exist a problem. Now, how to resolve this problem has two dimensions. You do it in the traditional manner, which you are doing, or you do it with the technology assistant. What we and taking liberty, I and you are advocating, is that because your traditional methods have not been able to resolve those things, you have to incorporate technology, whether it be BIM, whether it be virtual reality, augmented reality, into your project planning, into your project delivery, so that you can also have the taste of the same to resolve the problems. And we are sure from international studies and some example that I gave, that this would resolve those kind of issues. So the first step is, of course, to make industry accept that this is something which is happening. The
Exactly.
quality could always be, yes, the quality could always be improved from time to time, but the basics could be incorporated.
Okay, Dr. Farooq, the journey has to be started. You can always improvise as you go along, but then a lot of people dismiss it, calling it nahi yaar, bahut mehanga, very expensive. I mean, this is not a personal expense. This is an investment.
Solution है ना सर, उसका solution है. Why? मेरा सवाल है, अगर आप अपने इंडस्ट्री के हिसाब से देखें, I'm taking liberty because many of our audience would like to hear it in Urdu as well. देखिए, आप जरूरी क्यों है कि आप ये डिवाइसेस और सॉफ्टवेयर सारे के सारे खरीदे? Why don't you get it done from a consultant? उसकी कॉस्ट कम पड़ेगी. Why? आप बहुत सारे ऑर्गेनाइजेशन से ये काम कर रही हैं, हम लोग कर रहे हैं. आप इस चीज को, even if you want to as a prototype implementation, go with that. एक खतरा ये है ना सबसे बड़ा, कि आप पहले टेक्नोलॉजी ले आए, उसके बाद आपको कोई फायदा ना दे. So why don't you go with the expenses with the consultant, and then maybe you can decide on कि भाई ये काम ठीक है या हमें खुद इसको करना चाहिए. लेकिन there has to be a starting point. That is the point. There has to be a starting point. ऐसा नहीं है कि कंपनीज नहीं कर रही है, लेकिन उसकी जो डेप्थ है ना, जो फुल पोटेंशियल है ऑफ यूजिंग इवन इंफॉर्मेशन मॉडलिंग एंड वर्चुअल रियलिटी, वो पोटेंशियल यूज नहीं है. ये मेरा आर्गुमेंट है. वो पोटेंशियल तब यूज होगा कि जब आप उसको एक्सपर्ट्स के थ्रू और प्रॉपर तरीके से करवाएं. उसमें टू बिगिन विद, यू डोंट इवन नीड टू स्पेंड अ पेनी अदर देन ऑफ कोर्स व्हाटएवर सर्विसेज यू बी एक्वायरिंग ऑन इक्विपमेंट एंड ऑन हार्डवेयर. वो तो जरूरी नहीं है. उसके बाद आप चेक कीजिए, और उसको, ये तो बहुत आसान काम है. बिजनेस डिसीजन लेने की जरूरत है, ब्रेव होने की जरूरत है इसमें.
Yeah, don't forget licensed software. So, I mean, एक चीज है, Dr. Farooq, that the capacity building आपने mention किया, I'm sure the hosts can provide that.
Definitely, we also provide that. I see Mubin Saab is also here, so they also provide their solutions. So fortunately, here we are 2-3 different people who basically run different or work with different organizations who are continuously capable and providing capacity building. मैं तो even VR center में we even provide a program called Imagineering, which is called Virtual Imagination for Engineering, जिसमें we do not charge anything. We have graduated a number of students in that, जो कि हमारे साथ काम करते, चाहे students हो चाहे graduates हो, and they do hands-on learning for not 2 days, 3 days, but for a 40 days time minimum. इसके अलावा we can always have customized and dedicated training sessions for companies. असल में बात यह है कि मैं पर्सनली जो बिलीव करता हूँ वो जनरल ट्रेनिंग सेशंस पे नहीं करता. वो इंडिविजुअल कैपेसिटी बिल्डिंग तो जरूर करती है, वो कंपनी कैपेसिटी बिल्डिंग नहीं करती. सो व्हेन आई लुक फॉर कैपेसिटी बिल्डिंग एक्सरसाइज फ्रॉम वीआर सेंटर्स प्लेटफॉर्म, वी डू ऑफर इट फॉर द कंपनी. सो ताकि एक कंपनी के 5 लोग जब साथ बैठ के काम करेंगे वो अपने प्रॉब्लम्स को रिलेट कर सकेंगे, वो बेनिफिट को रिलेट कर सकेंगे, वो अपग्रेड कर सकेंगे कंपनी को. सो दिस इज आवर thinking of capacity building at NED VR Center.
Yeah, I mean, it remains a fancy thing until you make them realize that what you're doing is not sufficient. Anyway, आपके लाहौर और कराची, I mean, आप सिर्फ कराची बेस्ड हैं, लाहौर और इस्लामाबाद के लिए कुछ प्रोवाइड कर सकेंगे?
सर बिल्कुल कर सकते हैं. We do have actually I did not include the typical slides from my different presentations. इसमें VR Center की capacity है. Let me give you a brief overview of that. We have projection VR system, we have walking VR system, we have mobile system, we have HoloLens, drone. We are soon getting into laser scanning as well. We have virtual teaming systems, which we utilize. So we can always do virtual trainings, on-site training, off-site training, as well as we have just started our YouTube channel. So I would also request all the participants also subscribe, because normally our project showcasing is being done there, whether it be research project showcasing or commercial project showcasing. So that gives you a better idea of what we are doing as well. So we definitely can provide off-site capacity buildings as well.
ठीक है, offline discussion करेंगे. This is interesting.
Thank you so much, Farooq Saab. Thank you so much, Irfan Saab, for joining and presenting for our attendees. Any more questions from
I would also like to thank you, Mazhar and whole BIM Pakistan. You have been pretty active to arrange this week. I wish you all the success to this. This is a very unique and innovative idea. And I saw a number of good speakers every day till Friday or Saturday, I guess. So I will encourage the participants who are here to attend all the sessions.
Thank you so much, Dr. Farooq. And we really appreciate your support and your collaboration, sir. Thank you so much again, sir.